Yes, students, good morning. Jai Swaminarayan. In the last lecture of exercise 13.1, we have done up to sum number 5. Now, students, we are starting from sum number 6. Now, first of all, let us read the question and check what is given and correspondingly what is to be found out, students. A coin is tossed 3 times and we are given 3 pairs of events E and F, and a common instruction for question 6 to 9, find conditional probability of E given F. Now students, sample space of tossing a coin thrice is S is equal to HT into HT into HT, and this is equal to H comma T into HH, HT, TH and TT. Again this is multiplied and written as HHH, HHT, HTH, HTT, THH, THT, TTH and TTT. So these are the total 8 outcomes of the sample space. Now we are told event F, because F occurs first, heads on first to toss. This is given. So I am showing you then F. Event F heads on first 2 tosses. So we are to write the outcomes having 2 heads in consecutive order. So H, 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 H and H, 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 T. So the probability of event F is 2 by 8. We can write it as 1 by 4, but let us keep it as 2 by 8. Now event E, head on the third toss. This is the second event. Event E is equal to head on third toss, and correspondingly the outcomes are H, 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 then H, T, H and T, H, H. Now students, from event E onwards, you have to understand and write this in a slightly different way. We do not need individual probability of event E, but we need E intersection F, and E intersection F is given by a singleton set H, H, H. Therefore, the probability of E intersection F will be given by 8. Finally, the conditional probability of E given F, P of E oblique F, but always read this as P of E given F, which is equal to P of E intersection F upon P of F. So 1 by 8 divided by 2 by 8. So the final answer is 1 by 2. So this is how, students, we do the subjective problems of conditional probability, students. Okay, now the second part of the sum we are doing. So I erase these events. The ways remain same. So when erasing this events, let us check what is event F. At the most 2 heads. Event F at the most 2 heads. So we have to write, students, elements with 2 heads, 1 head and no head. So only element which is excluded is triple H. So this will have 7 variables. So this probability will be 7 by 8. What is event E? At least 2 heads. Event E, at least 2 heads. So here students, if it is at least 2 heads, we have to write all the outcomes with 2 or more heads. So here we have to write elements with 2 heads and elements with 3 heads. So this are H, 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 T, H, T, H, and one more, sorry, T, H, H. So at least 2 heads means elements with 2 heads and 3 heads. So E intersection F will be H, H, T, H, T, H, and T, H, H. So this probability will turn out to be 3 by 8. So the final answer is 3 by 8 upon 7 by 8, and that turns out to be, students, 3 by 7. So here you have to understand that this highlighted event F occurs first because it is the base event. We are told to find the conditional probability of E given F. Okay, let us do the third part of the sum. At least one tail. Elements with at least one tail. So I should write elements with 1 tail, 2 tail, and 3 tail. So this format remains the same. And event F at the most 2 tails. Event D, sorry, I should say event D. Event E at the most 2 tails. At most 2 tails. So we have to write elements with 2 tail, 1 tail, and no tail. So it is U minus T. And in the intersection, we will have 6 elements with the HHT, HTH, then HTT, THH, then THT, and then TTH. So this probability is 6 by 8. So the answer is 6 by 8 upon 7 by 8. So the final answer comes out to be 6 by 7. So now in this type of sum, students, you would have understood the algorithm. This is very simple, but students, you have to equivalently understand the subjective part, how to write the steps. Okay, let us do now sum number 7. Okay, students, now we are doing sum number 7. This base of the sum remains same. Let us do sum number 7. The sum is 2 points are tossed once. Now students, pay attention. The sample space of tossing a coin twice, or conversely, the sample space of tossing 2 points once remains the same. So this is our answer 7, and that turns out to be HH, HT, TH, and TT. So total elementary outcomes of sample space are 4. Now event F, 1 point shows head. Event F, 1 point shows head. So on any one point, either first or second, so this probability is 2 by 4. or half. Event T, tail appears on one coin. Tail appears on one coin. So the same outputs HT and TH. So E intersection F is either E or F, and that probability is also 2 by 4. So 1 by 2 upon 1 by 2. So students, the final answer is 1. This is a sure event. If it is asked to interpret the result, students, I would have definitely commented that this is a sure event. Okay, let us do the second part of the sum. Now, event E and event F definitely changes. Let us check, students, what are the given events. No head appears. Okay. No head appears means both are tails. So this is TT and this probability is 1/4. Event E, no tail appears. Okay, no tail appears. So definitely both are head. So E intersection F is null set, and therefore the probability of null set is 0. So the final answer turns out to be 0. If intersection of any two events is null set, then students, these two events are all mutually exclusive events. If students, intersection of any two events is null set, then students, these two events are called mutually exclusive events. And according to the definition, the probability of mutually exclusive events is 0. Okay, students, now we are doing next sum number 7. It's slightly different. Sum number 7. Sorry, 8. Sorry, 7 we have done. A die is thrown 3 times. Answer 8. Now, sample space of throwing a dice 3 times is cube of the set of elements consisting of integers 1 to 6. All of you know, students, whenever I toss a dice, the sample space for the random experiment is set of integers 1 to 6. Even if I toss it for the second time, we multiply set of integers 1 to 6 into set of integers 1 to 6, and same way for cube. So this results to 6 cube, and that is 216 elements. So I will not list all the 16 elements, but definitely I can say 216 elements, not 16. I shouldn't list all the 216 elements because it is a very lengthy process. In such case, we write only total outcomes. Event F6 and 5 appears respectively in the first two toss. 6 and 5 appears in first two tosses. So by default, in the first toss I should have 6, and in the second toss I should have 5. But I am tossing a dice 3 times, so correspondingly in the third toss I can have any of the 6 integers. So the favorable outcomes to this event are 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, and 6, 5, 6. That is why, students, I have written this in slightly different ink. Because we are not leaving a dice after tossing it twice. Students, dice is tossed 3 times. So corresponding to 6 and 5 in the first 2 tosses, in the third toss I can have any of the 6 integers. So this probability is 6 by 2, 1, 6. Then 4 appears on the third toss. Integer 4 appears on the third toss. So first and second should have 6 and 5. So here only one variable, which is 6, 5 and 4. So E intersection F is E, and this probability is 1 by 206. So the final 60, sorry, 1 by 216 upon 6 by 260. So the final answer is 1 by 6. Actually, this is a made sum. You shouldn't consider tosses individually, because you are tossing a dice to 3 times, and then entire sum is to be done. So if I say event T occurs after event F and it is told that 4 appears in the third toss, it means that in the first and the second toss we have already got integers 6 and 5. Okay students, now we are doing sum number 9, and I should say that this 9th sum was asked in the CPSC examination of March 2019. A very important sum, and this is, you can say, on the concept of permutation. That is why students are highlighting this is a very important sum. Now, what does the sum say? Mother, father, and son lying at random for a family picture. Sum number 9. Mother, father, and son. So 3 persons can be arranged in a row in 3, P3 is equal to 3 factorial is equal to 6 ways, therefore n is equal to 6. If you recall long back, before 7 months, I told that the fundamental of probability lies in the concept of permutation and combination. The fundamental of probability, students, always lies in the concepts of permutation and combination. So for the word arrangement, we have to use permutation. The formula of NPR, don't forget, n factorial divided by n minus r factorial, and the formula for combination is NCR is equal to n factorial upon r factorial into n minus r factorial. Let us write these 6 possible arrangements. This is our S. Say father is first. Then comes mother and son, or son and mother. These are the 2 arrangements where Mr. Father is first. Mother is first, then father and son and father. Same the son is first, then father and mother, and then mother and father. It is possible to write here these 6 elements because these are less. But suppose it was 5 persons and 5p5 is 5 factorial, which is 120. Then students, it is difficult for me to list all the 120 outcomes. But here it is easy. Now, what is event F? Father is in the middle. Event F, father is in the middle of arrangement. So sign out the outcomes where Mr. Father is middle. Then this is the first. And this is the second. Check, father is in the middle. So the variables are M, F, S or S, F, N. So this probability is definitely 2 by 6. That is 1/3. Now students, what is event T? Sun at one end. Sun at one end. So where Mr. Sun is at the end, say 1, 2, 3 and 4. So FMS, then MFS, then SFM and then SMF. So definitely E intersection F is F, and therefore this probability is also 1 by 3. So the required answer is 1/3 by 1/3, and that is 1. So whenever students we get answer is 1, we definitely say that this is a certain event, or we can say that this is a sure event. So question 6 to 9 had a stereotype label. Find conditional probability of a given f. Students, whichever event is given, that event always comes in the denominator, or that is the first event to occur in practice. That much, students, you have to perfectly remember, else the sums of conditional probability, students, are very easy to do and understand. Now, sum number 10. A black and a red dice are rolled together. So, fairly in your lower standards you study tossing of a dice twice or tossing of 2 dice once. The concept and understanding remains same. But here, the color is different. A red and a black. So, the sample space is writing 1R, 2R, 3R, 4R, 5R, 6R into 1B, 2B, 3B, 4B, 5B and 6B. And students, the total outcomes, when you roll a pair of dice, students, the total outcomes are always 6 square, and that turns out to be 36. Thus, students, you have to perfectly understand and memorize. The suffix indicates the color of the die. Now, the first part of this one. Find the conditional probability of obtaining a sum greater than 9, given that black die resulted in a 5. So, the base event, let me write as a, the black die shows integer 5, means 5b. With this, red die can result in any of the 6 integers. So, the favorable outcomes I am writing 5b 1r, 5b 2r, 5b 3r, 5b 4r, 5b 5r, and the last is 5b 6r. So the probability of event A is 6 by 56, and which is nothing but 1 by 6. Students, 1 R and 5b or 5b and 1 R is same. It means that the black die resulted 5. I could have flip-flopped the sets. That is not at all, you can say, difficult. main point is in 5b, I can have one of the 6 integers with suffix r. Given, find the conditional probability of obtaining a sum greater than 9. So event B, sum of integers is greater than 9. Don't consider 9. Greater than or equal to 9. So up to 3 doesn't count. Up to 4 also doesn't count. But let me write 4b and 5r. Or conversely the same, but I am keeping b first. Should I write this? No, because it is greater than 9. So I should start with 4b and 6r. Check, I have not written here equal to. Well, I taught the sum, the same thing I have reiterated. So 4b, 6r, 5b and 5r. Then 5b and 6r. Then 6b and 4r. Then 6b and 5r. And 6b and 6r. Now, what is a intersection B? Now that is easily understood. 5b 5r and 5b 6r. 5b 5r and 5b and 6r. So probability of A intersection B is 2 by 36, 1 by 80. Finally, the given event occurs first. So the conditional probability of B given A is P of B given A equal to P of A intersection B upon P of A. So the answer is 2 by 6 and that is 1/3. So this is how, students, this sum we have to understand and do. So one has to perfectly understand and then students write. The second part of the sum, students, I am leaving for you to do in homework. I suppose you can easily understand. The question is this: find the conditional probability of obtaining the sum A. So that will be element B. Sum of integers is 8. Given that the red die resulted in a number less than 4. Red die resulted in a number less than 4 means we have to multiply 1r, 2r and 3r with set of integers 1b up to 6b. So total outcomes of event A will be 18. Clear? And then sum of integers is 8. So I will have 3r and 5b, 4r and 4b and 5r and 3b. So this 3 pairs. Correct? But in the intersection, students, in the intersection, we will have which pairs? Then the only pair which is allowed is 3r and 5b. So correspondingly, students, you do the sum, and I hope, students, you should easily get the answer. You shouldn't have any problem, students, in getting the answer. Correct? So, students, you have to check and then write. I have only told the possibility. You have to check. The red die resulted in a number less than 4 correspondingly, and the sum of integers is to be 8. So even you can have 2r and 6b. Even you can have 1r and 5b. That I am not telling. Intersection you have to discuss in detail. I have given only 2-3 examples. 1r and 5b, 2r and 4b. That also you can have, isn't it? And 1r and 6b also. So that much students you can easily understand and try to do the sum. Now students, pay attention. I am discussing MCQ 16 first. I would like you to do the second part of the 10 sum. Students, I am in general discussing first students MCQ 16. What is given? All of you check. P of A is half, P of B is 0. Then what is P of A given B? Now no need of calculation. MCQ 16. P of A given B is P of A intersection B upon P of B. And if P of B is 0, this is undefined. So the correct option is C. The correct option is option C. MCQ 17. If A and B are such events that P of A given B is equal to P of B given A, then what is true? P of A given B is equal to P of B given A. So P of A intersection B upon P of B is equal to P of B intersection A upon P of A. So this gets cancelled, and correspondingly we have P of A is equal to P of B. So the correct option is students option B. So intentionally I have left the second part of 10 sum for you to do. Okay, we'll conclude the lecture. Thank you students.